Today we're going to talk about the algebraic properties. Now remember, you created in class a foldable with these properties on there, so I'm just going to recreate it real quick and go through some of those things that we have been talking about. So the first one that we talked about was the inverse property, and the inverse property stated this, that if we have a plus negative a, that equals 0. Or we could have negative a plus a equals 0 as well. Okay, what that means, by example, you have negative 6 plus 6 equals 0. We have 2.3 plus negative 2.3, that's going to equal 0. 4/5 plus negative 4/5 equals 0. If they are the same value, that's where the a comes in, and they're opposites, then when we add them, we get 0. Okay, so the next part is identity, the identity property. The identity property states this: a plus 0 equals a. Or we could take a times 1, and that still equals a as well. So 3 plus 0 is still going to be 3. Negative 5 plus 0 is still going to be negative 5. Okay, it can be a rational number, an integer, a whole number. It can be any of those. All right? Or we could take 7 times 1 equals 7. Negative 3/4 times 1 equals negative 3/4. We get back what we started with if we add 0 or multiply by 1. The next one is called the associative property, and the associative property deals with groups, okay, who we hang out with. So one of them says this: we have a plus b plus c, and a and b are hanging out. That's the same thing as a plus b plus c. So b can hang out with c instead. A, B, C, A, B, C. The order doesn't change. This also works for multiplication. A times b, and then times c, so they can be in a group, or a and then b and c can be in a group when we multiply them together. So something like 5 plus 3 plus 2. So if I add those two first, I get 8 plus 2 is going to be 10, or I could do this and say 3 plus 2 is 5, plus that other 5 is also 10. So it's the same thing. We get the same value. With multiplication, if I do 2 times 3 times 4, or 6 times 4 is going to be 24, that's the same thing as 2 times 3 times 4, or 12 times 2, which is 24. All right. The next one is called commutative property. The commutative property says that we can commute or move our numbers for adding and subtracting. So commutative, a plus b equals b plus a. Okay? Or a times b equals b times a. And we learned that a long time ago. 4 plus 5 is the same thing as 5 plus 4. Okay? 8 times 6 is the same thing as 6 times 8. They both are equivalent to each other. They equal the same thing. Okay, we have 9 and 9, 48 and 48. Finally, the last one I'm going to go over briefly is the distributive property, because I have a whole other video for distributive property. Here's what the distributive property says. We have a and b plus c on the inside. We can distribute this a to the b and c so that a times b, a times c. Okay? And if there's a subtraction sign instead, it's the same thing, only we take a times b minus a times c. And the way this looks is, let's say we have 3 and 2 plus 5. Well, our order of operations say that we would take 2 plus 5, which is 7. 7 times 3 is 21. But we could also do this. We could take 3 times 2 plus, and then I can do this part here, 3 times 5. So I distribute or give the 3 to both of the parts on the inside. Well, 3 times 2 is 6. 3 times 5 is 15. So when I add those, I get 21. And you're probably wondering, well, why don't I just use my order of operations? That works great, but when this really helps is if we have something like this. I have 2x plus 3. So I can't add x and 3. So I've got to distribute here. And so I can take 2 times x to get 2x, and then plus 2 times 3. So I would have 2x plus 6, because 2 times 3 is 6. I hope that helps. That's all for now.